Hello, and today I'm going to show you how to train a LoRA using Google Colab, a LoRA for Stable Diffusion 1.5. So the first part you would need to mount your Google Drive. And I've also had a bit where you download the data set that we'll be using for this training. I mean, if you're running this on your own, you can just comment this line out. So you don't need to do that. Next, the dependency installation will take roughly maybe about 5 to 10 minutes, maybe more, maybe less. Then here, you will want to select the model, the SD1.x model to use as the base model to train your LoRA off of. I actually prefer objective reality too, but you can also use the base Stable Diffusion 1.5, anything version 3.1 for anime, realistic vision for 5.1 for anything that's realistic. And I would actually say stick with objective reality 2.0 as kind of like an all-purpose model, whether you're doing realistic or anime. And here, download custom model. This is for people who don't want to use any of these models. So you would pick the blank spot here, and then you enter the URL for the model there. But here, and you may need to also include your Hugging Face token here. But in general, I don't use this, or if I do, I just have the model already on my Google Drive. Next, download the VAE. I would just download the standard Stable Diffusion VAE here. Next, you definitely want to change the setting here because as of right now, I'm having it train a LoRA on the data set of my cat. And you can see here, same cat here that I had shown you in the textual inversion video. And this data set has about 20 images instead of 6 from before. And yeah, the trigger word is CMMLRA, but we'll be using that later. So yeah, use use find the URL to your data set. Go to the files here. You can browse Drive, and if it's on any of these folders, let's say it's just in the root folder here, you would just copy the path and paste it here. Like I can just paste it right here. That's an easy way of finding your folder and where you have the data set stored. Next, creating the metadata file, I usually just leave this alone. And recursive, if you have any folders, subfolders with images below the main training data folder. Clean captions, I usually don't use that. I mean, that the original author had it here. Model directory, unless you're using a custom model that's not in one of the three options that I've that I've provided here, just leave this alone. You don't have to change it. Leave this alone. Leave this alone. Batch size of 16. I think that's optimal. You want 2 data loaders here for the bucket latent caching. If you're using a much higher resolution for your training set, you will want to bump this up. But I generally use 512 by 512 and leave this at FP16. I generally like to use flip augmentation unless you have a data set where the orientation left and right should be distinguished. And even if you didn't resize your images, this will resize and put it in buckets automatically. Here, the project name, I just put it the same as the trigger word, which I actually have in my data set here. So this data set actually this implementation actually requires you to have the trigger word the in the label. So I have CMMLRA here. as a trigger word and as a project name, but you can feel free to change that to something else. It's just a way for you to track it. And output directory, I just put in this LoRA test folder on my Google Drive. Next, dataset config, dataset repeats. Generally, I would look at this as you would need to take the number of images times the number of epochs later on here times and then divided by the batch size. And you want that number to be at least 1,000. So I have 20 images, 25 dataset repeats, and 12 epochs. And then a batch size of 6. So 12 times 25 times 20 divided by 6 is 1,000. So you would want that resolution, keep it the same as in the previous setting. Network category, pick LoRa. Here the dimensions, alpha and the dim, these you can just leave alone. These are the ones, if you're doing a LoRa, these are the ones that they actually look at. So for beginners, I would just say go with 128, 128. You might be able to get away with less if you're training a pretty simple LoRa like my cat here. Network weights, if you're resuming, you need to insert a link, a path to the latest checkpoint. Train text encoder. If you don't want to train the text encoder, I highly recommend that you do. But if you don't, you can uncheck that. So training configuration, if you're using weights and biases and you have an API key, you want to track your training progress, paste it here. The prompt, this is just for generating sample images. This prompt and negative prompt, these are what you would put into Stable Diffusion automatic 1111. So I just put CNN LRA and negative prompt, just put whatever you want there. And then I usually just keep these checked, sampler URA, but this is just for the sample images that we'll generate here. Like I'll show you here, right here, these two of my cat Mia that's already been generated. And then number of epochs, train batch size. You don't want to exceed 6 if you're using a T4, which is the free Colab. If you're using an A100, you can bump this up to about, you can bump the batch size to about 20. I haven't tried it on the L4, but let me see. I think the L4, but you can probably use a batch size of around 10 or so for that one. Save n epochs. So here you can either have it save every n epochs, let's say every 1 epoch, every 2 epochs, then you would put that there. If you want to save every 1 epoch, you change that to 1. I personally like to save every n epochs ratio is the number of epochs per training. So I generally like to have 2 or more. So let's just put 2 here. Save models as safe tensors. I prefer safe tensors. Max token length of 125. Clip skip. If you're training an anime model, set that to 2. Otherwise, 1 should be fine. Gradient checkpointing. If you want to have a much higher batch size, you can probably check that and bump this up. But generally, I like to disable it and just use a lower batch size. And gradient accumulation, if you want a higher batch size, but you're not able to, your GPU does not support it, and gradient checkpointing isn't giving you a high enough batch size, you would want to bump this up. You may need to reduce this to 5 or so without checkpointing, and maybe I think about you can probably get it to about 10 with checkpointing. And C, I just set it to -1. Then here's where you start training, and you generally don't need to change these 2 settings as well. So here, right now, we're about 51% of the way through with the training, and I'm going to meet you back once it is complete. All right, so training has finished, and here we can go and see what our LoRa is going to produce. So we want to navigate to the folder that we created where we wanted our output to go into up here. I think the folder that we specified in the output directory here. So I have that open in another tab here. And generally, you want to start with the file that doesn't have the 00006 or whatever number here, which are the intermediate checkpoints. Start with the latest one and see if it works well. If not, then we try the earlier checkpoints. So here, I've generated a picture of my cat Mia. Let's just use, I just keep a very basic prompt here. You have the LoRa at 0.7 strength. Usually it's not going to look very well at full strength, and that might be the case when your LoRa is overtrained. But usually it's a lot easier to deal with a slightly overtrained LoRa and set the weights down than to deal with one that's undertrained and try to boost the weights up beyond 0 beyond about 1.0 or 0.9 or something like that. So let's see. I'm going to generate one at 1.0 just for you to see. Basically, this would not, sometimes it would still look fine, sometimes it would not. Yeah, see, it's all fluffed up. So we can also bring it down to 0.5. If usually when you go below that, it's not going to look as great. So I mean, it really depends on LoRa. So here you see another tail coming out from her side, and you are probably aware that Stable Diffusion isn't quite good at the anatomies of animals, just like the anatomies of humans. But yeah, 0.7, 0.66 seems to be kind of the sweet spot for this LoRa. But just like any LoRa that you train, whether you use Colab or use another system, you would need to basically adjust this weight and see what the most optimal one is. And here, let's just try this one just for kicks and see if it gets you any better results. If it does, then maybe we should have trained for a lot fewer epochs. Let's try it at 0.8 maybe. Or even, let's try 1.0. Okay, so probably you also want to go with 0.7 on this one here. Generally, this is without any high high res fix here. Okay, yeah, 0.7 seems to be the sweet spot for these. Let's try a few more 0.7. Yep, and I think this is probably the better one. So if you're gonna try training on my data set here, maybe you want to go up here and reduce the reduce the number of epochs down from 12 to 6. All right, and that's it for training your LoRas in Google Colab. If you found this enjoyable, please like and subscribe to my channel. Thank you so much and have a nice day.